So it says, this is 4.5, number 12. And it says rational numbers and rational expressions are comparable because they have similar features. Complete the table by writing the comparable situation for each statement. So this is a very classic statement. Ms. Johnson says if it works with fractions, which are rational numbers, it works with rational expressions. So if whole numbers are rational numbers with a denominator of 0, that would mean that, let me type better. Give me a second. That would mean that polynomials are rational expressions with a denominator of 1, right? Let me highlight or something. I don't know. Maybe it'll stick out more. Okay. So this one says rational expressions are undefined when the denominator is equal to 0. Well, that's true for fractions too, right? So numbers are undefined when the denominator is equal to 0. Let me see if I can cut this real quick. That looks pretty good. Nope, that looks good, right? So when you add, subtract, multiply, or divide two rational numbers, the result is also a rational number. So is that true? When I add two rational expressions together, yeah, I get a rational expression. When I multiply, that's true. Yeah, it's all true. So I can basically take the same thing and put it over here, except for now, instead of putting rational numbers, I can put rational expressions will result in a rational expression, right? These are the same. Because it works in fraction land, it works in rational expression land. Okay, so when you add, subtract, multiply, or divide two rational expressions, the result is also a rational expression. So this is true. And this is actually, there's a term for this in math. It's called closure, where a rational plus a rational is a rational. I'm going to say that again. A rational number or expression plus a rational number or expression is equal to a rational number or expression, right? So like, for example, I know I always use this example because I think it's funny, but a bunny and a bunny make more bunnies, right? So that's called closure. So there you go. So last one, it says rational fractions are classified as proper fractions when the numeric value of the numerator is smaller than the denominator. This is where we're going to kind of like we're now not looking at the whole thing. We're talking about the degree. And this is something that I'm not even going to write down, to be honest with you, because we don't talk about proper rational expressions. I've never actually seen that, so I'm not even going to bother writing it. So this term of proper, and I actually don't like it when students come in and they're like, oh, that's an improper fraction. There's nothing improper about improper fractions. Actually, in the high school land, we like when the fractions are just that. They're fractions. They're not like mixed numbers. Mixed numbers, not helpful. They're helpful in the context of a situation, but they're not helpful in dealing with rational expressions, right? So if you wanted to write the answer for this one would be rational expressions are classified as proper rational expressions when the numeric value, so the degree of the numerator, is smaller than the degree of the denominator. Okay. And that's all I got. Thanks for listening.